Thank you. I can't see you all, but I figure that you are out there somewhere. Hopefully, the room is full. My name is Moshe Tzioni. I'm here to deliver something that I hope will grab your interest. And without revealing anything about the final presentation, of course, the main thing that we are doing here is talking about DDoS. And DDoS is something that mainly does not affect everyone, meaning that no one, not necessarily everyone is caring about DDoS. And why is that? Because DDoS is very, very widespread and everyone suffers from it. But on the other end, many does not. And many does not take special care about it. I'm here to tell you about mitigation, or more specifically, how to bypass those mitigations. And that in this way, we'll see that how effective DDoS can be. So I just revealed a bit. We'll be talking about DDoS. What is DDoS? I'll be skipping that in a moment. Methodology of work, how we do things. We attack by DDoS. I'm talking about my company, ComSec. We're an Israeli company that part of our services for 3 years now is DDoS attacks, DDoS simulations. It's more than an actual attack than a simulation, but it's called simulation for legal properties. And then when we talk about methodology of work, we'll reveal our structure and how we actually came to this presentation. Afterwards, we talk about DDoS tactics in the wild and how to mitigate those, how things need to work and how things working right now. So common practices and common strategies. Do not use the best strategies or best practices because they are not. And that's exactly what I'll be doing in the major part of this presentation. And the final part is what is called the call bullshit part, the Q&A. You can call bullshit at any time. I'm a big supporter of calling bullshit during the presentation itself and not waiting till the end. So if you do not want to be rude, you can sit down and call bullshit at the end. So any case, as I said, my name is Moshe Tzioni. I'm 3 years working on DDoS attacks through my company on demand, of course, and everything is legal. That's my first time in 44Con, and very excited to be here. And thank you for honoring me for listening for this presentation, and of course with the extreme league of personnel that is coming here. And finally, that's the end of shameless promotion slide. There will be no more mentioning of my company or anything like that. So the method is not so innovative, but special in our world of consultancy. We consult mainly for pen testing. I come for pen testing and pen testing here, I think 30 or 40 years. It depends from where you start. And through that, I've become the head of research for my company, and the 3 years now we're delivering the service that I'm talking about. The method itself is unique in that we are not only attacking, we are providing 2 teams, or 3 if you count the white team. We have a blue team at our customer's premise, looking at the logs, operating with the customer to see what exactly is having, and the attack team that is not in the premise and need to attack actually with the botnet that we have. I will not go into specifics because of as I said, it's an IP of the company, but you can figure it out. It's nothing very special. You can put out things that I say and then have a script on your hands that do the same. So the method, as I said, we play both Spock and evil Spock. And because of that, when we see together both Spocks, by the way, Leon and Nimoy just rest in peace, but the other one is missing. So if you find evil Spock, please let me know. In any case, we are providing both services at the same time, and through that, we can combine the logs and we can combine what each team saw, and then to figure out what is missing. And unfortunately, for most of our customers, they were missing a bit or a lot. And the final thing that we concluded that they are missing is the understanding of what DDoS is and what is affecting. And it's not the customer's fault as the vendor's fault, in my opinion, without hurting any feelings here, because the vendor itself is providing something that is that is need to mitigate about DDoS, and the customer should not be caring so much about DDoS if he has some big bulk of machinery that need to respond to DDoS. And through that, we bypassed the tactics and learn a lot in the process. So another thing that I want to tell you, that DDoS is for everyone. Everyone can do DDoS if they like. You do not need such a big botnet for that in most cases. In most cases, we are working on amplification and reflection attacks, and less on how big your cannon is. So everyone gets DDoS today in the positive term, I think. Okay, so you have the run-of-the-mill attacks, rely heavily on bandwidth, even though, according to SANS, a huge part of it is less than 2 gigabits per second. And it's pretty mundane attacks in 53% of the time. It's SANS from 2014, I think. And most attacks do not require brains. No one needs to know what exactly you need. Someone spreads out a virus and then create a botnet, and everyone does that. And then you have, in some cases, huge, in some cases, very small botnets, maybe 100, maybe hundreds, and maybe thousands. And in most cases, you do not receive like 1 million bots. Either way, the tools for DDoS are out in the wild, and many are using, or mostly using, reusing other code from the internet. It's pretty much the same with viruses. When we see a virus today, when we're analyzing malware, we see the common practice of malware, the common stages and things and signatures and things that correlate. It's the same thing with DDoS, and even worse, because no one is innovating anything, in any case in the wild. I don't know about the underground movement so much. So the attacks does not require brains, and our attacks are not require brains, I can assure you, but they needed to be analyzed before we are attacking, and the actual fine-tuning of those attacks are the things that put us inside the network and then to go boom with the DDoS. Another thing is amplification and reflection. I won't go over what is amplification and reflection, but maybe if you have some question about it. And we have received more and more information, we, the internet and the community, received more and more information about reflective attacks in the past 2 years, about DNS, NTP, and others. We have ICMP reflective attacks, we have IRC reflective attacks, and even torrent-based reflective and amplification attacks. So when we say strike harder, we do not mean larger botnet. It doesn't have to be that way. And that's the major thing that we figured. When you have a website, you think of a website or a front end, or you think of it as a back end. Most of the attacks think of the website as just a website, something to present content. And as you know, it's far from the truth. Websites are, the front end of the website is the least crucial thing in the system. If the website is not responsive, and everything is working in the back end, no actual damage, and I'm not relating to PR right now, that should be an effort, but no actual damage to the system or the data should have happened if you only attacked a front end. On the other hand, when you think of it and you try to hone down the back end and you try to figure out the logic that is going under the screen, when you try to attack the back end or maybe harness the back end for your exploitation, it's a major thing, and many times we saw beautiful attacks during our simulation and research that resulted from back-end mishappenings. Keep it stealthy. It's more than a rule of thumb, because when we're talking, and again, the equivalent to for a virus, you have antiviruses, and we all know how antiviruses are effective on these cases. And signatures in antiviruses is very similar to signatures that we find in WAFs, IPS, and yes, in DDoS mitigation boxes. And then when we find those signatures and understand them, it's most of the time the signatures themselves are not so complicated, because you want to be as general as you can. But on the other hand, if you are too general, and those are the cases many times, you cannot home down the next evolution of this attack. And this will always be a catch and throw a game on our situation. And many times with a small change to the same payload, even something as lame as loic, it can be modified a little, and then you can execute your code. And that brings me to maybe the best rule of thumb that I can give you is build your own tools. It's not hard at all. It's something that everyone that is involved with it a bit can write its own tools and write its own attack mechanism, even if it's the same thinking behind of loic and everything else that you know of DDoS tools. And again, if you build your own tools and payloads, you can fine-tune your own attack and again, be stealthy about it. The last thing that I want to emphasize is generalization of amplification. And when we see amplification mainly in media misuse, is amplification of the network itself. In NTP and DNS, there is an amplification by that when you send a DNS query, you can receive a huge bulk of information on the response, and then it's a proper amplification between what you send out and what the other site via your spoofed address received on the final end. And that's a great example of amplification. But if we remember the first rule, there is nothing less important than the front end in the website. And when we do amplification just on the network, it won't be the same as if we are attacking something else. And we have 4 things to attack, 4 pillars we call that, that wouldn't surprise you at all. 4 pillars of attacks. One is, of course, the network. That's the usual suspect. The second thing is the CPU. When I think of something that I'm sending to you, and then your CPU is working much harder than my CPU, it's a great amplification and a great example of amplification, and usually work very well. THC did some work. If someone from THC is here, I will be happy to shake hands with them. THC did some work with SSL and SSL renegotiation, and this part of the arsenal today for DDoS. And SSL is a great example of both network side attack and a CPU or memory attack. During the calculations, this has been done with some kind of research from their side. They received up to 24 times the amplification, or on the standard side, it's 16 times more than the client CPU that is working from the CPU that is working on the server side. Meaning that every payload, every connection that I'm making with SSL is making the server work much more harder than myself. And think of it in terms of DDoS, that can be pretty devastating. So that's CPU. We have memory, that again, memory, we are talking about non-volatile memory that can be consumed and can be exhausted in no time, in many times. And storage, of course. The disk space is something that nowadays is pretty vast. You can, but under a DDoS situation, you can fill up a disk to its fullest, and the most volatile for that is actually the network boxes that contain a not so large amount of data just for keeping logs and such. And if there is no log rotation on the machine, or maybe a very slow log rotation, like once a day, you can be filling it out, and then maybe crash down the system along the way. And that's the final thing about amplification. Amplification does not actually affect only the server side. It affects the whole traffic along the way. If you have IPS firewall, if you have switches, everything can be attacked. Sometimes you can home down the single point of failure that you want to home down, and many times you just unleash the attack over the network and hope that some kind of the backbone will be failing. One good example for that, and I think I've discussed it with someone from the audience earlier on, is about databases. Databases is a huge part, and we'll be coming back to databases in one of the examples. So just before we start the countdown from 10 to 1. It's going from the least common and the most pervasive until the most crucial and most successful attacks, and the most embarrassing, actually, attacks for our customers. So just before we start, no shaming policy. I will not, of course, uncover the client identity. Will remain anonymous. We'll call it Superbank, meet Superbank. There will always be one. And we will present 10 common practices of appropriate mitigation, so-called appropriate, and then bypass and attacking those. So ready, set, Facebook. 10, limit the rate of incoming packets. That's the most common thing that we heard from our customers, and many got over that. Limit the rate of incoming packets means that every IP that is sending you information can be limited. That's the idea of a very, very classic DDoS attack that says that the major thing that attackers do is to choke the bandwidth, and then you can't signal anything to the world. That's a very primitive way of thinking about it, and many of our customers and mitigation techniques have overcome this thinking, but it remains out there. Even we found some of those remains in a booklet that one of the vendors gave to one of our customers. So limit the rate of incoming packets is maybe true, but it's not very effective, or not very effective at all, because usually when you have a bank that is consumed with its bandwidth, okay, no matter, I just skip that. So the attack itself is relying on the reflection side of things. If we attack in a web server, that's most of the cases for attacks for us, but we can attack many other things. When we have attacked some weird thing in the past, but mainly websites. And when you have a website presents pages, and not only HTML, it can be JPG, it can be JS, it can be anything else that contains data. And when we deliver some kind of a GET request, we need to get something out of the server. And via that, we can keep our limit or our request, incoming packet request size to the minimum, and then the website will be reflecting to us the actual file that we requested. That's the only thing that you need to know about this attack and this bypass of the mitigation. So that's pretty easy. When we send like 1 kilobyte of GET request, and we request I don't know, let's say a megabyte of a file, that can be that's a mainly thing that it is affected is the of course network side of things and the network amplification. But you can handle both big and small size files unless it's bigger than 1 kilobyte that is getting out as a GET request. So that's pretty easy. That's consumption by reflection, and pretty easy to mitigate, actually, and pretty easy not to think about it. The number 9. It's okay now, monitoring shows everything is back to normal. That happened when one of the vendors, one of the biggest vendors for back then it wasn't called cloud, but now it's called cloud protection from DDoS. And actually what they've done is just to say that all the traffic went under their servers, and they can scrub out the DDoS attacks, and then only legitimate data will get to the server. Of course, it's a very hard mission to accomplish, and the thing is that monitoring cannot show you all the thing. Via this thinking, think about it for a second. If you have something that is going through other servers, and let alone security about it, if you have different servers that is going through that, you have to have DNS resolve for those servers. Think of if you have some kind of a server in London and you want the scrubbing service to work, it has to pass by the scrubbing service, so the DNS records will be updated to the scrubbing service. And then, when you use the DNS to resolve those IPs, you'll get to the provider, and then through the provider, you'll get to the actual site. But if you know the IP of the actual site, you can, in this case, just attack the actual site with IP without regarding to DNS. So again, that's pretty lame to think of and even to execute, but just to figure out what was the last IP for that, and then you can counter the site by yourself. But in this case, the worst part of thing was that the only thing that they were shown is the monitoring. And when you look at monitoring, as all of you may know, is that monitoring can lie to you because you can't monitor at all. But then again, many of our customers do not know how to handle DDoS because they rely heavily on vendors and rely heavily on logs. So when you have this mega common practice now went to buy all anti-DDoS solution. They buy it all, and then monitoring shows that there was an attack here, and then afterwards or before that, there was no attack at all because everything was mitigated. So they detected the attack, and then the attack was mitigated, so all was fine. The most crucial thing that they didn't know all this time is the site was down for this long and afterwards. The only thing that they shouldn't do is not relying on the logs and just try to surf to the website. And that's exactly what they didn't do. And they didn't try to surf to the website, and they didn't try to understand their faults. So again, pretty lame and no bypass there, just relying on monitoring is something that many SIEM and SOC teams do, and even IRT teams do. But in this case, it was very crucial, and we are talking hours of activity for DDoS and no surfing to the website at all. Number 8, backend servers are not important and to protect against DDoS. As I said, databases are mostly backend. You won't find many websites that will tell you, okay, just connect to the database and search for your local store. But in many cases, you have a front end that actually rely on, in most cases, rely on database. Think of Tesco. If you go to locate a store for Tesco and you search for a store, it will have some logic inside that will tell them what database to approach and how to approach it. So that will be containing in every site that you know. The amplification of that is something very, very massive, because each and every one of those connections to the database can spawn more than 20 and many more connection requests to the database because of the logic, how the logic works. And if we don't think of DDoS as something that attacks our backend, we won't protect against it, and we won't try to exhaust the thing with the DDoS, with the database when we build it in the first place. So how can we figure out that there is a database that's worth attacking? Just think of time. That's a time side channel that we can just measure. There was a time that we actually measured 20 seconds between our requests that took the site to question several databases and then back to us. There was much rejoicing because we figured that in this case, of course, there is much talking to the many sessions to the databases, and through that we were pretty sure that our research before the attack will accomplish a great and beautiful attack. And in this case, the attack was very successful. And if you think of it, the database will never, in the short term, will never be protected properly through DDoS, through the common practices today. The only thing is that if you have some kind of a protection or stress testing against your database, maybe you're safe. But I don't know of many customers that do that. Number 7, it's a very common practice in some parts of the world. You buy one block of a thing you need to protect against DDoS, and then you think, okay, I have many domains, let's protect it all. And then you switch it on and try to figure out which cable goes to where, and then everyone are happy because you bought one thing to many, many domains. But again, it's not so good practice if you don't know what you're doing. In one case, actually, a customer in the UK approached us and said, listen, I have this new box, this new shiny box that we bought, actually some kind of a startup in the terms of DDoS. We haven't heard about the machine before that, but we researched a bit about it back then. And then he said, okay, I'm ready for the attack. I connected such and such servers, and I think everything will be fine, and you have no option for success on the attacker side. In this case, the machine was constructed via something pretty particular that took 20 seconds to accomplish, meaning that during 20 seconds, it will only learn. If it detects something that is susceptible to be an attack, it will learn the attack for 20 seconds or maybe a bit more, and then come to mitigate it, start the mitigation mode. So in that case, we attacked and nothing happened. Nothing happened for 10, 15, 19 seconds, and then in the 20th second, it just went went black on all the servers for the system. We attacked only one server, but what was happening is that he connected all of the domains, including the monitoring system, to the box. And the mitigation policy for this box was that if the mitigation is detecting properly a DDoS attack, it will switch off the domain and try to what is called draining out those sessions, and then to start all over again. And then you have the specific true to false, positive and negative connection to the database and to other servers. But when the mitigation went off, it decided that everything is now is not okay because everything is connected, so it's the same server, so we thought. And then everything was blacklisted. So when it was blacklisted, everything went off, and even the monitoring, and it couldn't figure out a way to penetrate this kind of mitigation. And actually, for 6 hours I think it was on Monday, he couldn't do any operation on the systems. And the final thing that put something in perspective is that one of the servers was the backend server was actually relying on some kind of a correspondence between servers, and then it couldn't do that because everything was black, it was shut down. And when it happened, it caused a major error that needed to be debugged for several more hours then. So understand the mitigation technique that you implement when you buy a new and shiny tool. We don't trust the vendor. We don't give them certificates. Something is very wrong about this sentence, except the bad English, of course. We don't trust the vendor. That's something pretty common that we heard from maybe many companies that relied on cloud services. The problem with cloud services, in against to on-premise services, is that you have to provide them with an SSL certificate in order to open up, in order to decrypt and encrypt or encapsulate the SSL traffic. Without that, they can't see the actual traffic and then cannot mitigate it. So when you don't trust the vendor, you don't give them the certificates in the first place, you can't see anything. And you are not the only one that can't see anything. The vendor can't see anything. So that's, of course, a very problematic approach, and that is very easy to attack. And as I said, SSL is one great thing to do when you want to amplify your attack on both CPU, memory, and network on the same time. And maybe, just maybe, even though it's not mentioned, the storage itself will maybe log your correspondence, and then you have a full-pillar attack in one attack. The only problem that I haven't mentioned is the sentence itself. If you don't trust the vendor, don't work with them. It's that simple. If you don't trust your vendor, if you don't trust of them to mitigate your attacks or to taking care of some kind of security, you are not trusting them, don't use them. You have to trust something that you use. That's something that is pretty easy for this audience to understand, of course. Number 5 is we need big data. Collect all the logs. Big data is a very common mistake nowadays. Maybe you heard about it. So big data is something pretty funny because everyone thinks that they know what big data is, and big data means big data, means that you need to collect all the logs. So first, it's not what it meant. Big data is something completely different, as you may know, but the other thing is collect all the logs. If I collect all the logs, I have to be sure that I can collect them and I can store them, and maybe, just maybe, I will be, in this case, and you actually should know that because you have heard the presentation and you have brains. So if you have a storage room and you want to, and it can be filled in a short term maybe with a DDoS attack, pretty soon you will be shouting silo needed. And if silo needed, you should take care of the result of that, and you want to maybe put something down, so like kind of monitoring, and maybe do not collect all the logs unless you have to collect all the logs. So that's just was fun. And in one case we had in this super bank, of course. We had a case that the bank was on a holiday. Holiday means that the bank doesn't working, but the crowd was massive. The amount of session was very massive, and we did the attack overnight. as most of the attacks that we do, because we want to give some kind of off-peak hours, but in this case it was a holiday, so it wasn't an off-peak hour. And it has something that he thought that will be in use, that the IPS will collect all the logs that it can have, and there was 24/7 around-the-clock reading of those logs by a human being that can read it and then to know how to mitigate the attack that is occurring. In this case, he was in a place and he knew that we are attacking. The only problem is that he couldn't figure out a way to log into the system because the log was flooded and actually flooded the device. It was an IPS without mentioning the vendor because it's not its fault, of course. And the IPS was so filled with data so no one can log in, not via web or via telnet or in this case SSH. So he couldn't just log into the system and then to see what is happening inside. He needed to go to the server room, which is another geographical place, and just reset the machine itself by hand. And it took some time for the bank, and it was pretty amazing to see. So in case of the IPS, you wouldn't think of the IPS as something that will cause you in a DDoS, but in many cases, as I mentioned before, the network devices are those that are most susceptible because they have a short, many times they have a pretty small space for storage, and the CPU is not that hard unless it's a CPU that is dedicated for something like the SSL accelerators and stuff. So network devices are best for those attacks and many times are not part of the chain that is controlled by some kind of a DDoS mitigation unless the DDoS mitigation is in the first place of line of attack or defense. Okay, so number 4 has happened several times. And one time it happened, I think last time it happened for us, it was with a client in Australia that just bought a new and shiny on-demand scrubbing service. The on-demand scrubbing service is something pretty peculiar because when you think of a scrubbing service, you think of it as something that is working around the clock. But an on-demand scrubbing service gives you the opportunity or flexibility to operate it anytime you like. If you are under attack, it can be switched on and switched off. Their premise is that you can switch it on all the time. But if you want the flexibility, they can support that and will give you the opportunity to just switch it on with a flick of a button, and then you have an on-demand scrubbing service, which is a great opportunity for you just to spend some more money. So an on-demand scrubbing service sounds fine. The only problem is that, as I said before, if you don't know what a tactic is and if you don't know how the system works, you should never have used it in the first place. In this case, it was devastating because okay. I think that I'm missing a word here, so I'll take it by heart. All you have to do is they have an attack. The attack was pretty much of non-success, the first attack that we had on this customer, because it went well. There was much of a slowness on the website, but still possible to interact with, and everyone could log on to their bank account. But then he thinks, oh, I have some kind of a DDoS attack right now, and I want to mitigate it because maybe in 10 seconds or maybe an hour from now, it will be amplified in some way, and then I can't handle it. So I know I can flick on the on-demand scrubbing service. Great. Not so much, because the on-demand scrubbing service in this case did something very similar to signature-based or mitigation that we encountered in the UK. At that time. It learned the traffic first and then mitigated it. But it did it in a somewhat unfashionable way because the 20 seconds, sorry, in this case it was several minutes. In the several minutes that it was operating, it learned the traffic and considered it white. All the traffic that it received, and I just, a quick reminder, it was under attack at the time, all the traffic that it received got a white label. So when the mitigation kicked in, the white label couldn't help them and actually amplified the attack itself because the correspondence with the scrubbing service caused some amplification that eventually brought down the site and 2 other servers as well at the same time. So in this case, the on-demand scrubbing service maybe was great in the first place, but not of the term of use that they was presented with. On top of that, the nice Australian that we've worked with just called the scrubbing service support and woke someone out of his bed with his PJs or something, and then he didn't know what to do about it, and woke another manager on the floor, and things got down a bit hectic, and the final solution from the vendor was, next time you can buy from us an integration service that we can provide with and then customize the effect for your system. It was a big no from our customer to the vendor, but in any case. Okay, we move on to some CDN stuff. CDN is a great thing, and I'm not joking here. A CDN is a great thing when you think about DDoS. What CDN does is content distribution network, of course, is just delivering your stuff around the world, and then you actually have some kind of you spread your net, and then you have you can overload the system, but you can't overload it all, right? But then again, you have maybe in several cases you have some kind of attack that you imply on yourself. In this case, you have a CDN that is not dynamic. Most of CDNs are not dynamic, meaning that they do not query the site all the time, and they can figure out what all the parameters that can be given, because it's not a final solution set. Everyone can give a search, another search term. Everyone can give another option, and it's not something that is a final set of solutions for the problem or for the query from the database, let's say. So most of CDNs are not dynamic. One or two of them, the major ones, provide some kind of a dynamic systems, but I won't talk about it right now because they don't handle DDoS, and they don't say that they handle DDoS properly. So in the case of not dynamic CDN, it's okay, and of course, as I said, it's a pretty good idea actually. But again, if you use it improperly, you will get into some trouble. In this case, we had an actual attacker in one of our customers, and then we mimicked this situation in other customer. When you attack a CDN, you have a problem. As I said, you can't handle, let's say, in the UK alone, you have more than 1,000 or 2,000 servers for a single CDN. And then you can't bring down 2,000 CDNs or servers that is spreading out. And of course, if we think of a DDoS that is spreading out from around the world, you can't hone down just single server. Usually, you want to hone down all the servers once because you don't want the site to be active from anywhere in the world. So in this case, the only thing that is working with a non-dynamic thing is the cache. When you have CDN, you have cache, meaning that you have a final set of solutions, and every solution that, if someone is searching for a term, let's say A, you think of A of a parameter, and then this parameter is got listed in the cache, and then when the parameter A is coming back, you know how to pull it off the cache. If the B is now in place and you don't know about B, again, it will select it from cache, and then next time you ask for B, you get it from the CDN. But if you deliver some other parameter each time, it will have to ask the origin its meaning, because it doesn't have this kind of information. And you can utilize that. You can exploit this kind of behavior just for this cause. If you are looking at an attacker and just asking the cache servers, and the CDN, you're just asking for other parameters and randomized parameters, and it's not configured properly to not against a dynamic website. So you will have actually a DDoS botnet utilizing the CDN. And what's worse is that the origin of the attack will be from the CDN itself. And if the website itself is monitored, you won't see from where exactly the attack is happening, but you will see the closest node for that attacker. And if an attacker brings down one of the cache servers, he will hop on without any effort to the other one, and then continue on asking. So the first line of mitigation won't help, because it will be the thing that will bring down the site, and maybe will give you trouble in mitigating it in the first place. So that's got a pretty high standard in our facepalm approach. Number two, is actually something that is working under CDN as well. And this one is a screenshot from a website that is providing advice on how to mitigate those attacks from DDoS. So it gives several options. It's snipped from graphic reasons, of course. You can view the site, just look for Google, how to protect CDN, and it will give you this. For me, it was like the second request that I got from Google. So I was wondering how people are protecting the CDNs. And the second part is, there is a simple trick, and it is also the best solution. Create some random long set of alphanumeric characters and use that as the subdomain. The thing is that the origin, your own website, need to be protected, because if you disclose the actual website that is running the server and not the CDN itself, maybe you can attack this, right? So the first thing is that to make it undistinguishable, and maybe someone won't happen to figure out what is the proper domain name and couldn't be actually knowing what is the actual IP for the origin domain. Again, origin is your on-premise machine, or maybe your own machine that is not part of the CDN. Just the CDN is redirecting for that and providing a screen for that. So the last sentence is great. Can it be guessed? Yes, but highly unlikely. Can it leak? Yes, but again, highly unlikely. What do you think about those sentences? We think it's bullshit. And the only thing is that you have so many options to discover what is the proper domain name for something, that you don't know. First of all, so in this case, we have a very long stream of bytes that we need to maybe figure out, and no one can know about it. So actually, you can know about it from several reasons. So how to find invisible origin? First of all, if you know subdomains, if you know other subdomains of this customer, or this, let's say you have CNN.com, and maybe www.cnn.com is under a CDN, but maybe ftp.cnn.com isn't. So you look for those domains first place and enumerate those domains. When you have those domains, you can scan the 24 or 16 CIDRs, and then you have a good chance to finding it there. But we are working on chance here. We are just throwing out the bone to just maybe, figure out what is the website. So it's not sufficient when I'm talking about bypassing. The other thing is pretty neat, and it saves us a lot of effort many times before, and it usually works. It's a human error. Who is never forgets. When we query the who is service, we have the last who is, but we have some services around the internet that provide us with history of the who is and IP history for those DNSs. So the first thing that our customers do when they have a big bone of CDN service just waiting for the origin to pop out is that before the CDN was up, because that's a proper evolution of a website, you just bring out the website, and then you have so much requests, so you need a CDN, and then you upgrade to a CDN, and you forget all about the last IP that you've been on. But the internet never forgets. And through that, we've just checked. You have, for example, viewdns.info, and we use that in this case, and we just have a screenshot from a malware-infested site named bing.com, if you know about it. So in this case, so this bing.com have a who is history, but of course we haven't tested Microsoft without their permission. But in our customer's case, we have the same IP history, and if the last, or maybe the two last histories was from the CDN itself, the one before that will be the original origin IP that they have used. And we have some pretty funny stories about that, because in most cases, we just find out the IP that actually the origin resides on, and the IP cannot be protected properly because no one is doing ACL on that. The proper ACL from most of CDN vendors is just saying to the customers, protect from the header that is requesting a GET request. Just look for a specific header in our cache request, and that's another option to send out a proper message from the CDN vendor without giving out names right now, but you can find it on the internet. Look for the CDN vendor, look how he used to send out a GET request to the website through the cache service to the origin, and then you can get the the identifier that they use, and then maybe query the IPs that you found in the first place. But if you have those, you can attack the last IP. And so we have several cases that last IP was very useful. And in one case, it was pretty peculiar because we actually attacked the last IP, but the origin wasn't there. We thought the origin was there. I didn't say so, but before the attack, we spent like a week of work to actually research the site and gather information and intelligence about it, electronically, of course. And then we can modify our tools and do things in specific, like fine-tuning the payloads and see what is the limit and how to exhaust it to the maximum through nothing like intrusive attacks. So in this case, we actually attacked the last IP used, and then the attack and three other sites were down during build process, which is pretty huge for this. In this case, it was a bank in Italy. And then it went down, and it all got black from this moment until 2 hours after, when the build servers were up. They're doing some kind of a nightly build for the systems. So what happened in this case, that they used the last IP because every company and organization have a pool of IPs that they need to use, because it's too shame now that the IPv4 is gone. So you have an IP under your organization that you need to use, and he reutilized this IP for redirection purposes between servers. And then we attack this server and actually hit the backbone, and it's a mother load because all the servers that is interconnected between the two, and majorly the www one was hit badly. So in this case, that's number 2, and it's happened a lot more in the last year now. Number 1 is not so great technologically, as it is a big win for an attacker that understands what you're doing. So the tactic is there for one more reason, is that it's the most common tactic that we found. Block them. Now them, now them, now them, now them. And the meaning is that every alert that you get to the SOC, you just say, okay, it's an alert, I see a DDoS, I see a LOIC, okay, that's an attack, just block them. And maybe when you have 1 attack or 2 attacks or 3 attacks, when you are not playing out like a robot, you can actually mitigate the proper ones. But let's think about it. If I have, in this case, we had an insurance company. It was in Israel, actually. And actually, Israel is pretty small in terms of IPs, but let's take UK, for example. In the UK, you have 119 million addresses, IP addresses that can be directed to one or other organization. And you have this pool. And in this pool, let's break it down like 1,800 Class B ranges. Why I'm mentioning that is that in this case, in Israel, we have like 2 million, just for comparison. And when you have this insurance company, they had all the stuff, all the staff on the floor waiting for us to attack and then respond with an let's block them. And now it gave us pretty much the headache, because it's not, let's say, fair if you know that someone is going to attack you and then you mitigate it by hand, and they did it very horribly. And then we decided to play some fun on this. And actually, every attacker can figure it out, because we figured out that they are blocking us. We attacked from some subset that we have around the world, and then saw that from one machine that was blocked, the other group of Class B was blocked as well. So, excuse me. Forgot to drink. So the other Class B was blocked as well. So it's a pretty easy deduction, right? And then when we have this in mind, and we know that they are waiting for us, and then they actually automate it. Think of it as a monkey blocking every single incoming alert. And then it will take us in the UK like 15 minutes in comparison to this attack to self-inflicted DDoS, because they actually covered all the UK, in this case Israel. They covered all the Israeli traffic from getting into their site, and they have like 98% of customers from Israel. So it's pretty self-inflicted DDoS. We just invented a term that I don't think that someone is using. So don't use that. So like in the UK, in comparison, it will take us 15 minutes. In Israel, it will take us it took us like 1 minute to 2. It depends who you ask. And in this case, it's number 1 because it was hilarious and all of us got a great laugh. Maybe 1 or 2 doesn't. So misconceptions that we went through is that there is no magic pill. You can't just buy something out and then use it and everything will be okay. DDoS is a subset of DOS, not the other way around. It's important to know this because DOS is much more effective if someone have an exploit for your site, or even slow loris, which is kind of DOS more than a DDoS, of course, but is used via DDoS as well. DOS is much more massive, and one single point of failure will get you down. And DDoS mitigation does not pretend to defend against DOS, just against DDoS. It has its shots, but nothing in particular. And you can have toys and money in the world. Best mitigation: don't do drugs. Don't use your mind in order to mitigate, not just to think of it as of a play for something like combining some stuff and toys, and then you get mitigation. And DDoS is easy. Try before you buy. If you have a DDoS machine and you want to protect against it, put it on a test, put it on a stress testing. It's just play it around. It's pretty easy. You have stress testing tools that can help you as much as DDoS tests itself. And the last part is, if you want to do that, you can be evaluated for this presentation in the future. That's a promise, not a threat. I think that's it. Any kind of question or calling bullshit? Is the time. Thank you.